This is Mrs. O'Neill for Chapter 3, Review Questions and Problems. So you're going to go through this video by pausing when you see the question or the problem. Now you can do them again mentally or write down the answers. I will strongly suggest though this time, especially because a lot of it is mathematical. This was a math chapter. You might want to write at least the problem down, or not the problem, but the solution, to make sure that your dimensional analysis, the setup that you do, is the same as the setup that I have done. So just to kind of give that to you. Sometimes there are multiple parts, and then of course the next slide is going to be your answer. And again, if it's a mathematical question or something that you have to use dimensional analysis for, I will also show you the work, the solution. So make sure that your work as well as the answer and unit matches mine. So we want to also go through these. There's two prefixes that you're going to see in this review that are not part of your packet. So you might want to get out that list. Remember, from mega to milli. We need to know nano is actually 1 and 9 zeros. Nano for 9, smaller than a regular base unit. So again, 1 meter would equal 1 to 9 zeros nanometers. Okay, so it's that many times smaller, and pico has 12 zeros associated with it again, and it's smaller. Pico you're not going to see very often, but nano you are going to see not only in this review, but you will see it in a couple of chapters. So again, pause the video, read the information, and come up with your answers. Hopefully this makes sense between accurate and being precise. Number 2. So hopefully you pause the video, and if you don't remember your sig fig rules, hopefully you went to that part of your packet. So not only did you come up with an answer, this is the correct answer to the correct sig figs and rounding. So pause and make sure that your numbers are exactly these numbers. Number 3. Answers. Number 4. And again, this is where you would need to know the nano versus the pico. And I highlighted the end there because that's your base unit. So all of these are getting smaller, and these would be getting bigger of your prefixes. Number 5. Answer. Number 6. Answer. 7. Now the denominator, guys, is the bottom part. What has to be true about that bottom the bottom unit? 8. Now this is a math problem. So again, you're going to want to see the dimensional analysis setup. So not only what you're starting with, your conversion factor, your answer, and your unit. So ladies and gentlemen, hopefully you paused, and not only did you come up with an answer, but you can show me that you know exactly how to set up the conversion factor. Number 9. Answer. Number 10, and there's nanometers. There's that nano again. Here's your answer. Again, we're going to be using nanometers in future chapters. I also gave you the answer 2 different ways, the regular way and the scientific notation way. So unless it specifically tells you which way to write your answer, it doesn't matter. They equal each other. It's just a different way of writing the same number. Number 11. Answer. Now this is a 2-step dimensional analysis problem because you have to go to your base unit first. Remember, that base unit is a unit without any prefixes. 12. And I also want to remind you here that conversion factors do not go towards sig figs. So I did try to give you the answers to the correct sig figs, but unless it tells you, you don't have to worry about that. Remember, I usually go to 2 decimal places. So once we are done with this chapter, ladies and gentlemen, you are not going to have to worry about doing your mathematics according to sig figs. And usually I just go to 2 decimal places again, but this chapter on specific questions, it will tell you because that's what we are testing you on. Number 13. Again, guys, this is nano here. And I also started the problem, not in scientific notation, but I just, again, made it into a normal number. And again, when you're doing scientific notation, you can use that EE button on your calculator. 14. Now this one's a little tricky because you have to change 2 units. You have to change your top unit milliliters to microliters, and you have to also change your bottom unit of minutes to seconds. So this is a multiple conversion setup dimensional analysis problem. So hopefully you paused and hopefully you wrote it out and got this as your answer. Again, pause and make sure that your conversions look exactly the same. 15. I want to remind you that milliliters and cubic centimeters are exactly the same unit, right? It's a 1-to-1 ratio there. So for every 1 milliliter I have, I also have 1 cubic centimeters. So just in case you have to look over your work again. Also, again, this is another kilograms to grams change of unit and your bottom liters to milliliters change of unit. 16. And here's your answer. 17. And in this case, I'm giving you the answer 2 different ways. I use the formula way of, the formula way down here, density equals mass divided by volume, or you could also do it the dimensional analysis way. Because remember, we talked about how density, since it is a gram per milliliter, it's its own conversion. So you can do this problem either way. And 18, again, is above and beyond. This one's not going to be on the test. But again, I know some of you guys like those little challenges. So again, pause the video and see if you can come up with an answer. And here's your answer. So again, this is really a percent problem. So it's part to a whole. So not only are you using dimensional analysis, you're doing that part to a whole kind of thing. So if you got this, great. If not, that's okay too. But for those of you who like those little challenges or those little puzzles. And pause the video and make sure that you can do all these things. Besides reviewing them in this video, just make sure that you can go through this and do all of these things for the assessment. And see you in class.